Okay, thank you. So, yeah, so thanks for introduction. I'm Wojciech Tyczynski. I work in Google for the last 4.5-ish years working on Kubernetes, focusing mostly on scalability and performance. And this is what this talk going to be about. So let's start with thinking what scalability really means. So let's take a look into, as a first approximation, what Wikipedia says. So it's saying that scalability is the property of the system to handle a growing amount of work by adding resources to the system. In computing, scalability is a characteristic of computers, networks, and so on and so on. An example is a search engine which must support increasing numbers of users, and there are a number of topics it indexes. So it's not super useful. Imagine that we are giving this definition to our users. It will mean nothing, basically, to them. So we need something else. We need to come up with something ourselves. So what does scalability mean? What do we have on our minds where we are saying that we are working on scalability? And there are basically 4 main pillars of scalability work that I think there exist. Those are defining what scalability really is in our particular system. What does it mean that our system scales? The second is improving the system to match users' expectations. The third one is testing infrastructure. I think all of you who were working on scalability or were trying to prove that your system scales, you all know that it's, on one hand it's hard, but on the second hand it's super expensive. So we need some frameworks to make scalability testing more approachable. And the fourth pillar is tests and guarding our system against regressions. So one thing is achieving some particular scale, and the second thing is ensuring that it doesn't regress over time. But in this talk, I'm going to purely focus on the first one. So let's try to look into that. So it's pretty clear for users that they want the system that they are working with, they want them to scale. So for example, if they know that at any point in time they will not need more than 10,000 machines, they want to know that Kubernetes scales to, let's say, 1,000 nodes. But what does it really mean that Kubernetes supports or scales to 1,000 nodes? And the answer isn't really clear for that. It's not obvious. And what is more, if we ask users what does it mean, what they want to scale, they don't really know that. Why? They just don't want to know what it really means. They don't want to understand all the infrastructure, in majority of cases, how it works exactly, which in our case is Kubernetes. They just want their cluster to really work at that scale. So how do we approach defining scalability, in particular in Kubernetes? I'm going to, all the examples here will be based on Kubernetes, but many of the things here are pretty generic and apply to any system. So how do we approach that how did we approach that? And the definition of scalability is relying on 2 main concepts. The first one is SLI, which is service level indicator. You can think about it as some metric that we are gathering from the system. And the second thing is SLO, which is service level objective that we build on top of that SLI. And you can kind of think about it as a metric plus some threshold. So with having those concepts, we are saying that a cluster works or scales this idea of introducing SLIs and SLOs works both for like scalability, but it also works for correctness and availability or any other aspects of your system. So we are saying that the cluster works, or scales in our case, if all the SLOs that we defined are satisfied. Okay, so we roughly understand like how the high-level idea looks like. So let's take a quick journey into like what was happening 4 years ago and how we started defining scalability back then. So in 2015, we said that we introduced basically 2 SLOs. One was API responsiveness, where we said like 99% of API calls return in less than 1 second. The second was pod startup latency, where we said that 99% of pods and their containers has to start within 5 seconds, assuming that their images are already pre-pulled on the nodes. And as you can imagine, it's really far from where we would like to be. And this definition has a lot of drawbacks, but I would like to focus on the main 2 ones. The first one, I think you can probably easily imagine, is poor coverage. So you can imagine a situation that networking in your cluster is completely down, like pods cannot talk to each other, they cannot reach any external services. It's like any inbound traffic to the cluster is not working. Networking is completely broken. So if that is because of scalability, then obviously your cluster doesn't scale. But our SLOs that I mentioned on the previous slide can easily be satisfied in that case. So it's pretty clear here that we need something more. But there is also another problem, which in my opinion is actually at least as important, maybe even more important, which is lack of precision. So let's take a look as an example to the API responsiveness. Like, how do we aggregate different types of API calls? Over what time period we are aggregating? So I bet that if I take one of you and myself, and we will get 2 different interpretations of those. You may probably say that I'm working on that for like 4 years, so maybe it's because of that, but I bet if I would take like any 2 of you, we would also get 2 different interpretations. Like there are so many of those that it's highly probable. And why is it actually dangerous? Why it's a problem? So imagine a situation where in my interpretation, the SLOs are satisfied in your cluster, and in your interpretation, they are not. So you as a user are saying like, you promised me that this will be satisfied, and it's not. So it doesn't work for me. And I'm saying it works. And the problem is that we are both right here. So it's pretty clear that we need something better. And we basically were realizing those problems from pretty much early beginning. So let's see how we tried to approach those problems. And let's focus on the coverage problem first. So the first real attempt to address this problem, or first significant one, was in April 2017, when I wrote this doc of like target SLIs and SLOs in Kubernetes. It was basically 10 pages of text with ideas for like 18 SLIs and a number of SLOs on top of those. Neither of those have precise definition. They were like very vague ideas for things that we should be covering that are not covered. It still required a lot of work to make that really happen. And as you can imagine, like it didn't bring us that much farther. And the problem was obviously a scope. So even though like I was explicitly excluded a bunch of things from that initial attempt, like we explicitly excluded things like stateful applications, we explicitly excluded batch. It still have like significant interactions with like at least 9 SIGs. including API machinery, node, apps, auto-scaling, auth, network, instrumentation, storage, and obviously scalability. So looking a little bit deeper into that, like we would probably need like 20-ish approvers for that doc and like 50 or more reviewers. So I bet it wouldn't be approved even by now, and probably not by the end of 2022 even. So we obviously needed something more shorter term. And I guess you might be thinking that I'm trying to show that we need more iterative approach. Yes, that's true. We need more iterative approach, but that's not the main thing that I'm going to focus on. Because, in fact, this document gave us something that is super important. It gave us basically a product surface. So what is product surface? So it's basically a set of functional areas of our system. Also like APIs, features, and like flows that we give to users and are making our products. So it's basically having a product surface is very important for two reasons. One is quite obvious. It lets us to more have a clear set of things that we believe should be somewhat covered with the SLIs and SLOs. But there is also like a second thing that is very important, which is it completely changes the way how we can talk to our users now. So instead of asking a question like, what needs to scale? What do you want to scale? Which users don't really know answers for, and they cannot really answer it. We can start asking something more specific. So do you care about like feature X? Like is X taking Y seconds fine or not for you? And this is something that users actually can answer, and they are happy to answer, and they want to help us with asking those questions. So this document, even though like we didn't make any progress for introducing any specific SLIs, it gave us this product surface that completely changed the way how we were able to talk with users to make further progress. But what about other issues? I mentioned also lack of precision. There were a couple other issues too. So how did we proceed with addressing those? So basically what we needed was a framework to define SLIs and SLOs on top of those. And there were a couple of principles that we came up with in order so that we would be able to create those SLIs and SLOs. So let's take a look into those. So first of all, something that we already discussed is that they need to be very precise and well-defined so that everyone has same understanding of those SLOs, of those SLIs and SLOs. So the second thing is consistency. Like they need to be consistent with each other. In systems like as huge or as wide as Kubernetes, where we expose like hundreds or maybe thousands of features or APIs to users, we can easily imagine having at some point tens of SLIs. And if each of them will be using different terminology, different concepts, different phrasing and stuff like that, users will never get to that. They will never understand it, and because they will be bored by, or they will just stop reading that at some point. And if we use like a common terminology, common concepts, common formulas in all of those, like it significantly helps with understanding those. The third thing is, which is something that I already was kind of alluding to, is that they really need to be user-oriented. So the last thing that we would like to have is having an SLI or SLO that users don't really care about. Why? Because very non-negligible overhead of having an SLI. You need to earn the SLO. You need to maintain it. You need to ensure that it's still like up to date. You need to adjust it to changing product. You need to ensure that you don't regress it. You need to debug and fix regression and stuff like that. If no one is really caring about that, like that's a wasted work. And finally, the SLOs has to be testable. So there are basically two ways of measuring. Like ideally, we would like all the SLIs to be measured in any live cluster that can exist. But in some cases, it's just either very hard or very, very expensive to do that. So imagine that you, for example, would like to measure a network latency between any two pods. Like, that's something that can be measured, but potentially the overhead and the cost that users have to pay for that by more used resources is very huge and for many users non-acceptable. So while we are trying to make all our SLOs to be measurable in any cluster, we allow for cases where some of the SLOs can only be measured in some synthetic benchmarks. So we have those principles, but that's still not enough for providing SLOs. So let's take a look into those couple things. So what if the cluster is misconfigured? If, for example, your control plane components are under-provisioned, we know that the SLOs probably won't be satisfied. Second thing is like extensibility. It's something that a lot of users really takes advantage from. It's something that a lot of users really love, and it's why they are using Kubernetes. But it's also like a way that you can shoot into your foot. So basically, let's say that you are installing a webhook that is doing sleep for 5 seconds. That basically means that the API responsiveness SLO cannot be satisfied. So what can we do with that? And there's also like a third thing here that is like very, very interesting, which is like the performance characteristic of your cluster very heavily depends on the load on the cluster. So there's significant difference when you are, for example, starting 1 pod per second versus like starting 100 pods per second. And this aspect is actually very interesting. So we came up with the concept of scalability dimension. So an example dimension is, for example, number of nodes in the cluster, number of pods, number of services, and stuff like that. And on top of that, we introduced this concept of scalability envelope. A scalability envelope is basically a subspace of configurations of your cluster for which we know that the SLOs will be satisfied. If you are interested in this topic, there was a great talk by Shyam and Maciek on last KubeCon. So I recommend watching that. But going back to our main topic, like this concept of scalability envelope is one of the things that allowed us to really build a final framework for defining our SLOs. So how do we do that? So what we are basically doing is we are saying that if you promise that you correctly configure your cluster, that you keep your load within the limits in all the dimensions that we have and stuff like that, then we promise that the SLOs will be satisfied. So this is basically the framework that we are using to define our SLOs. So let's take a look what we did like to refine the SLIs or the SLOs that we like introduced back in 2015. So let's take a look into API responsiveness SLO. We already seen how it looked like in 2015. This is to what we refined it, or actually half of it, in 2017. So let's take a look into a little bit details into what exactly happened here. So first thing is that we explicitly splitted SLI from the SLO. This is like very important because SLI is a way of measuring things. Like it defines how do we measure stuff. SLO is only like saying what do we guarantee for those metrics and when do we guarantee and stuff like that. So let's take a look like how do we define those. So first of all, we explicitly say what is being measured. So in this case, it's like latency of mutating API calls for single objects. In the exact definition of the SLO in our page with SLOs, it's like the mutating is also defined. It's like post, put, patch, delete. I guess I missed something. But anyway, so we are explicitly saying what exactly we will be measuring. There's also a sibling SLI with SLO for read-only API calls, but that's not like the purpose of this talk is not to like familiarize you with all the SLIs and SLOs, but to give you an idea like how you should be doing that if you would be doing that in the future, either for Kubernetes or for any other system. So we are saying what is measured. Then we are saying like how we group that. So we are saying like for every resource verb per, which basically means it's not a single number for this SLI. It's basically a number of it's number of those streams of values which is like separate for every resource verb per. And finally, we are saying that like how do we aggregate stuff over time? So we are saying that it's like 99th percentile over last 5 minutes. In general, we don't want to. We recommend looking into some percentiles, not into average or like max or something like that. Those are generally bad metrics to provide guarantees for. So yeah, this is about SLI. What about SLO? So first of all, we are saying when exactly we guarantee something, and like basically what has some guarantees. So we are only saying like in default Kubernetes installations. Why is that? It's because, for example, of the problem that I described with extensibility. So we would like to avoid situation when someone installs, for example, a webhook that completely breaks performance of Kubernetes, or if your Kubernetes cluster is like misconfigured in some way. And then we are saying that we are providing guarantees for every resource verb per, but we are excluding something. We are explicitly saying that we are not providing any guarantees for any virtual and aggregated resources and CRDs. Like there's one caveat with CRDs is that, as you might have heard like during one of the keynotes, like CRDs are on their way towards GA. And as part of that way, we will be introducing some SLOs for CRDs too. We are trying to push according to our rules to make the SLOs consistent with each other. We would like to just get to the point where we'll simply like remove this exclusion of CRDs here, but we'll see like where that goes. But I really hope it will end up with that. So hopefully like within the next month-ish or so, the SLO will evolve by just removing the CRDs from here. And finally, what we are saying is like what exactly we guarantee. So we are saying that 99th percentile per cluster day is like less than 1 second. So are we done with that? As I mentioned on the previous slide, not really, because of the changing world and the fact that CRDs are going to GA, we'll probably be changing it to also include the CRDs. But that's still not there. That's still not everything. Like, based on different discussions that we have with users and among developers, this SLI is still not exactly reflecting what our users really care about. So imagine a situation that 99.9% of your calls, for your calls, we are returning like 4 to 9, which is like retry after, and that finishes super fast. And for the remaining 0.1%, all the API calls are taking like 10 seconds. Is that really okay? It's probably not, even though the SLO actually will be satisfied in that case. So one thing that we would like to do here is to explicitly exclude requests that kind of weren't processed, and to include only requests that had reasonable response for users. There are still some details that has to be figured out here, but it's probably the way we will be evolving that. It's becoming more and more important, especially in the context of what is happening now, which is there is like a whole effort of providing a proper like request prioritization, rate limiting, load shedding, and stuff like that in API servers. So that topic is becoming more and more important. So even though we have something that looks pretty reasonable, we are still not there yet. So this is just to point you that like defining SLIs and SLOs is also a very iterative approach, similarly to how we are like making software in general. So how exactly the process of defining SLIs and SLOs look? So to summarize that, like we are basically adding or refining some or removing potentially an SLO if it's something that none of the users really care about it at that point. What is happening next is that based on that, we are updating scalability envelope, because new SLOs means more restrictions, which translates to different limits on different dimensions. In the meantime, our product is evolving, so new features are added to Kubernetes or to any other system. So we need to update the product surface. And based on that, based on all of those, we need to talk to our users to understand what are the things that they really care about from those new features. Are the SLOs that we currently have is what they expect, or maybe they want to have some other guarantees. And it's not only about like the exact values, it's also about like, as in example in the previous slide with the API responsiveness, where things like requests that we are saying retry after shouldn't be counted towards the SLI. And based on those discussions with users, we are going back to changing the set of our SLIs and SLOs. So to be more precise, like this doesn't exactly look like a circle. There can be arrows between any other any two items here. It's basically because like product, like life cycle of the product is not necessarily tightly coupled with life cycle of how we evolve our SLIs and SLOs. Yeah, so what is the current state of where we are currently? So we are still in the point where there are only like 3 official SLIs and SLOs. Those for API responsiveness, one for read-only and one for mutating calls, and the refined but still the one for like pod startup time for stateless application. But there are also like 5 more, what I call like work in progress SLIs and SLOs. Those are SLIs that are already precisely defined. They are approved by all the interested parties. They were discussed with users as things that those users really care about them. We are working on having a proper implementation of how we measure those. working on having tests that are exercising those and stuff like that. But I really expect those, or at least some of those, to becoming like official SLOs, hopefully in the next, 1.16 release of Kubernetes. Just to clarify, like out of those like 5 SLIs, 4 of them are oriented around networking, and 1 of them is like more around storage or around storage applications. But there's still a lot of work to be done. So, for example, we don't have any SLIs or SLOs or any guarantees around concepts related to apps. We don't have any guarantees for deployment, stateful set, or anything like that. We have some ideas, but there is, we didn't came up to any like reasonable conclusion with something that is like really user-oriented, generic, measurable, and stuff like that. Although there are some ideas that are that hopefully will converge to something like that soon. Okay, yeah, so that's roughly what I had to head for today. So as you can see, just to summarize, as you can see, there's like a lot of work that has to be done in this area. And as I mentioned in the beginning of the presentation, this is just one of the pillars of the scalability. Like there's way more work to be done in the improvements area or infrastructure or tests themselves. So if you are interested in helping us with any of those, like please join Scalability or please talk to me directly. We will definitely find you some interesting work to work on. So yeah, so that's I think what I had today for today. So do you have any questions? Thank you.
So one of the limitations of the SLI-SLO approach is that it only catches regressions when they pass a certain threshold. Is there anywhere that we're actually looking at basically increasing response times short of them transgressing an SLI?
So I think it's more in the area of like testing and testing infrastructure. Yes, we would like to catch them. We are working like as part of like extending our testing infrastructure and stuff like that. We are working on being able to monitor the test runs themselves, not only to summarize the test, to build graphs where we can look into how different things were changing over times overrun. We don't have any alerts yet or anything like that that are catching what you meant, those kind of regressions that didn't pass the threshold. It's something on the roadmap, but yes, I agree it's important, but it's in slightly different category in my personal opinion. But yes, it's something that is on the roadmap. It's just not the highest priority.
Hi, hello. Thank you for the talk. I have a question. So those SLI, they seems to me like they are the Kubernetes from the Kubernetes for the platform users. I have a lot of developers, and often they ask me, do we have any SLI, SLO for Kubernetes? Because what they care is like, I want to deploy, I know that I can deploy on the clusters. When I do a network call, it's going to work. My DNS request is going to be solved. If I need to scale up, the cluster autoscaler will work. So I was wondering if you know anyone or any work done in trying to define the SLI, SLO to provide to Kubernetes end users, like people writing application on Kubernetes, or how we can build any of those.
So this is exactly for end users. Like
okay.
This is what is targeting for end users. Like, for example, like pod startup time, like as being one example, is exactly what you are working for. So yes, there is some work happening, for example, for like how fast cluster autoscaler will react. Like this is exactly this effort. So we are lacking a bunch of stuff here, but yes, we are making some progress at least.
Thank you.
Anyone have a question?
Okay.
Oh,
one more.
there we go.
I don't see a mention of the size of cluster when it comes to the SLIs and SLOs, because I think that the size of the cluster will also matter. I mean, when it comes to us guaranteeing the pods getting started in a specific amount of time and all that.
Yes, so this is what I mentioned here is one of the dimensions, like number of nodes, right? So basically size of the cluster. So this is exactly what we are saying here in this like framework, that like you need to keep your workload within the limits. So we are saying that only if your cluster is like within the limits that we support, so currently it's like 5,000 nodes, only then like we promise that the SLOs will be satisfied. Was that the question, right? Okay. Yeah, so this is basically this part. So yeah, something that maybe wasn't clear, like this is like the overall framework. It is kind of like on the top of all the SLOs. I didn't put it here explicitly, but it's basically for every single SLO we have this like if it stopped working. Anyway, so we are basically saying that like yes, only if your cluster is within correctly configured, like within the limits and stuff like that, we provide this one.
One last question. Oh, it's a comment.
Yes. Hey, so I want to just comment on this question. So I think the point is that while the number of nodes does influence the latency, for example, so you basically have a function from the number of nodes. Like if you keep everything else constant, the number of nodes is going to influence, let's say, the pod startup time. What we're trying to do is not to enforce a particular function underneath, or the shape of the function, or the curve, whatever. We're just trying to make sure that no matter what the node size, as long as it's within the limits, so within the promise, it's not going to exceed the SLO. So of course there will be some change, right? It will be lower for, let's say, in a 10 nodes cluster. This will be much faster than 5 seconds. But you're not trying to enforce the curve. You're trying to just enforce a threshold and say it's never exceeded, no matter how you move along this dimension.
Yeah.
And it's already a difficult problem. So for the curve, I imagine this would be way too difficult.
One last question.
Okay. Thanks for coming.